Hey guys, today we're going to be doing this AP Chem problem, and it says to give a complete galvanic description of this galvanic cell. A galvanic cell basically consists of two half reactions, which are redox equations, so which means that one of them is going to be reduced and one of them is going to be oxidized. A complete description of a galvanic cell is going to include your E, your total, so the sum basically. It's going to include the balanced equation, and it's going to include U denoting, which is occurring at the anode and cathode. So in order to determine this, which one's going to be reduced, I'm going to look at my my standard reduction potentials, which are here. And I notice off the bat that if I were to flip this, my E formation, the total, my standard one, would be a negative number, because it would be 1.16 plus negative 1.5, and you can see this is 1.5 is greater than 0.16, which means that it would not be thermodynamically favorable, not occur typically. So that means that this is going to be the one that's flipped. So now I have this plus, I'm going to flip my Cu equation, so Cu plus as a solid that is decomposing to Cu2 plus aqueous plus 2E, sorry, not solid, plus 2E minus, and my E now becomes negative 0.16 voltage. And when I look at this, I'm gonna ignore this for right now. When I look at this, I can see that Cu is going from Cu plus to Cu2 plus, which means that it's being oxidized. And when I look at Au3 plus, it's going from Au3 plus to Au0 as a solid element. So this is being reduced. So the first thing I'm going to do, I'm going to actually do number 3 because I basically just said it, but 3 to denote the anode versus the cathode. Well, the anode will be wherever the oxidation takes place, and we just said that Cu plus going to Cu2 plus is it being oxidized, so the anode is where the Cu is, and our cathode is where the reduction is going to take place, which is our Au. Okay, and now we have to balance this equation. What balancing means is that we need to cancel out the amount of electrons, and I see that there's 3 electrons here, and I see that there's 2 electrons here. So in order to cancel here, you must do a least common factor method. But, oh, I'm sorry, I think I just realized I copied my Cu wrong. It should be like that. Okay, sorry. Okay, so now I must cancel them. So in order to cancel this, I could just simply multiply by 3 to get the electrons to cancel out. But then I have to distribute this 3 to everything there. So I'm going to simply rewrite Au3 plus, the electrons are going to cancel, times 3. Then Cu plus times 3 will give you 3 Cu plus. Then you're done with the left side, and then you have to go to the products. Then you have Au plus 3 times Cu2 plus, and your standard reduction potential here, the total would be 1.5 plus negative 0.16 to give you a value of E total equals 1.34 volts. And that would be your answer. And also, basically, when you're solving these, you should know that you're never going to multiply the voltages. So let's say I have to multiply all of this by 3. You do not multiply this. This stays the same.